Hi viewers, in this video we will solve problem 8.28 from the book Heat Transfer J.P.Holman 10th edition. Here is the statement of the problem 28 from chapter 8. Two parallel discs 50 centimeter in diameter are separated by a distance of 12.5 centimeter and enclosed by a large room at 300 Kelvin. One disc is maintained at a constant temperature of 800 centigrade and has an emissivity of 0.8. Other disc is perfectly insulated and has an emissivity of 0.1. Calculate the net radiant energy lost by the discs maintained at 800 centigrade. Also, the data that is provided in the statement is the diameters of the disc. So this is diameter, d is the diameters of the disc, that is 50 centimeter. So if you convert that into radius, just divide dia by 2, so you will convert into radius. So 50 divided by 2, you will get 25 centimeter. Further upon, just divide this with 100 to convert into meter. Distance between these two discs, so this is, let's say, disc 1, this is disc 2, and the distance between these two discs, that is x, and it is given in the statement, that is 12.5 centimeter. 12.5 centimeter. This is at a higher temperature T1, this is at a lower temperature T2, and the room temperature is T3, in which these two discs are enclosed. Temperature T1, that is 800 centigrade. Convert that into Kelvin, just say 273 with it, so you will get T1, that is 1073 Kelvin. And the temperatures of the room, that is T3, it is 300 Kelvin, and the temperatures of the other disk is unknown. The emissivity of the disk, that is at 800 centigrade, is 0.8, and the emissivity of the second disk, that is 0.1. So we need to find the radiant heat energy lost by the disk, that is at 800 centigrade or 1073 Kelvin. That is our concern. In order to find the shape factor from f of 1, 2, we need the ratio d by x. So d, that is 50 centimeter, d by x. So d is 50 diameters of the disc, and x is the distance between these two discs, and it is given 12.5 centimeter. 12.5. So this ratio will give you 4. So look at this here, this is the ratio 4, the d by x ratio that lie here 4. So just move forward and let coincide with this curve, and it will give you the shape factor 0.61. The shape factors between these two discs, that is 0.61. Now from the summation rules, f of 1 plus f of 1 2 plus f of 1 3 is equal to 1. So the shape factors of f of 1 1, f of 1 2, f of 1 3 must be 1, because this is a flat disk, so its shape factors for its own will be 0, and the shape factor for f of 1 2, that is determined from this graph with the help of d by x ratio. So I can say that here you will put its value, that is 0.61 plus f of 13 is equal to 1. Now you can say f of 13 is equal to 1 minus 0.61. So you can say f of 13 is equal to 0.39. So this is the shape factors from 1 to 3. Okay, so the area A1 of the disk is equal to the area A2 of the disk, that is pi r square. Pi is constant, r is 0.25 square. So after calculations you will get area that is 0.1963 meter square. We have determined the shape factor from this graph. So further we didn't have any use of this graph, so I will remove this from the display so we can get the maximum workplace. Okay, now I want to draw the resistance network diagram of this bodies, that is plates and one is the room that is enclosed in it. So first the emissivity of the body 1, then its surface resistance, then its radiosity J1, EB1, then space resistance, and then emissivity and radiosities of the body 3. So in this case the surface resistance is 0 because the room is very large in shape, so its area is very large. So in the since its surface resistance is 0, so we can say that J3 is equal to EB3. And there is another body, that is the disk. Surface resistance is 0 because it is perfectly insulated. So we can say that J2 is equal to EB2, and the heat transfer between J1 and J2 is occurs, and in between there must be a space resistance. So similarly, the heat transfer that is occurs between J2 and J3, it will face the space resistance between them also. Okay, so the resistance, this resistance is equal to 1 minus emissivity 1 divided by A1 f of 13. This is equal to 1 divided by A1 f of 12. This is equal to 1 divided by A2 f of 23. So here I can say that this is resistance 1, this is resistance 1, this is resistance 2, this is resistance 3, and here this is the resistance 4 that is offered to the heat transfer. So these are the resistance R1, R2, R3, R4 that will be offered to the heat lost by this disk that is at 800 centigrade, and the heat that lost from this disk will be transferred to the second disks, and the environment temperatures, environment room temperatures, that is a very large area. So that's why its surface resistance is considered 0, and that's why J3 is equal to EB3. Here I can say that A1 f of 1 P is equal to A2 f of 2 3. So this area A1 same with the area A2, it will be cancelled out, so we can say f of 13 is equal to f of 23, and that is equal to 0.39. So here I will calculate all the resistance that is used in this resistance network diagram. So the first resistance is R1, and its value is 1 minus emissivity 1 divided by area 1 emissivity 1 minus what is emissivity 1, that is 0.8 divided by area, that is 0.1963, multiply 0.8. After solving it, you will get the resistance R1 value, the heat lost, that is 1.2735. Here resistance R2, here resistance R3, here the resistance is R4. So we need to find the resistance, the equivalent resistance at node J1 and J3. So we, if you are interested to find the resistance in between J1 to J3, so these two resistance R4, R3 are in series and R2 are in parallel. So first we will add simply R4 and R3 to find its equivalent resistance, that is in series. So we will say that the sum of the R4 plus R3, that in series, is equal to R5, and it is equal to, what is R4 value, that is 8.351 plus R3 value, that is 13.062. So after solving, you will get R5 value, that is 21.413. So the addition of this resistance R3 and R4, because these two resistance are in series with each other, so that's why we add it. Now the equivalent resistance R4 will be in parallel with R2, so I can say that the equivalent of 1 over R5 plus 1 over R2 is, let's say, the equivalent resistance of these two series that are in parallel is R6. R6 I can write in terms of this formula: R5 multiplied by R2 divided by R5 plus R. What is R5? 5 is 21.413 multiplied by R2, that is 13.062 divided by its sums, 21.413 plus 13.06 equivalent resistance, so that is R, and you will get its value, that is 8.11. Now the resistance value that you obtain, that is R6 value, that is 8.113, is actually the equivalent resistance that is included in this triangle, that is R2, R4, R3. So the equivalent resistance of R3, R4, R2, R6 that has been calculated, and it is 8.113. So this resistance R6 is basically in series with the resistance R1. So in this way, by adding the resistance R1 and R6 of this resistance network diagram, you can find the total resistance that is offered to the heat lost by this disk, that is at 800 centigrade. So here I can say that total resistance that is offered to the heat lost by the disk, that is at 800 centigrade, it is R6 plus R1. So R6, that is 8.113 plus R1, that value is 1.2735. 1.2735. Upon additions, you will get the total resistance. Now the EB1 value is equal to sigma T1 to the power 4. Sigma value is 5.67 multiplied by 10 to the power minus 8 multiplied by T1, that is 1073 to the power 4. After simplifications on calculators, you will get its value, that is 75,146. So the heat lost by the plate that is at 800 centigrade is equal to EB1 minus EB2 divided by the total resistance that is offered to its heat lost. So EB1 minus EB2, this EB1 value, that is 75,146 minus 459 divided by the total resistance, that is 9.386. After simplification on calculators, you will get the heat lost by the disk, and its value is 7957.2. 7957.2, that is lost by the disk that is at 800 centigrade. And this is our final answer. I hope you understand. If you still have any confusion, you can ask in the comment section. Please subscribe my channel if you haven't subscribed yet, and also share with your friends. Thanks.